Hello friends, welcome to my channel. Today the topic of presentation is spontaneity, and this is very important topic from thermodynamics, and most of the questions are asked from spontaneity in NEET-UG and other competitive examinations. So let's start the topic. Friends, the reaction is said to be spontaneous when it is self-generated. That is, there is no need to initiate the process again and again. And the phenomenon is called spontaneity. For example, flow of river downward. This is the case of spontaneity. Second one, flow of heat from hotter to colder body. This is also the example of spontaneous reaction. So this is the concept related to spontaneous process or spontaneous reaction. Okay, remember this point. Now after this spontaneous or spontaneity process, we have criterion for spontaneity. The criterion is given by Gibbs-Helmholtz equation, that is delta G is equals to delta H minus T delta S. This equation provides the overall criterion for the feasibility of the process. Here the delta G is negative for spontaneous process. Remember this point, very important point. Second one, delta G is 0 for process is in equilibrium. Third one, delta G is positive for non-spontaneous process. And this phenomenon is also justifying that for process to be spontaneous, delta H and T delta S should be favorable. Favorable means it should lead to the result by which delta G should be negative or delta G is negative. So there may be different cases when delta G is positive or delta G is negative. So here I am listing out the different cases when delta G is negative. 4 cases are shown here. First case, when delta H is negative and T delta S is positive. So these two values are always returning negative value for delta G. So at all magnitudes it is spontaneous. Second one, we have negative values of both delta H and T delta S. In that case, delta S should be greater than T delta S for negative delta G value, that is for spontaneous process. Third one, both are positive. When both are positive, T delta S should be greater than delta H. So the process will be spontaneous. Lastly, we have positive delta H and negative T delta S. It always returns positive value of delta G. So it is always non-spontaneous and it can never be spontaneous, and we can say that at no magnitude it is spontaneous process. So remember this table. The questions are mostly asked from this table or from this equation. Now before moving to the questions from previous papers, look over the concept. Now we have questions, problems from previous papers, NEET-UG 2017. In this question, it is given that for a given reaction, delta H is equals to 35.5 kilojoule per mole and delta S is equals to 83.6 joule per Kelvin per mole. The reaction is spontaneous at temperatures are given, T 425 Kelvin, be all temperatures, T is greater than 298 Kelvin, T is less than 425 Kelvin. To solve this question, we have to recall the criterion for spontaneous reaction. That is, delta G should be negative and delta G is equals to delta H minus T delta S, that is shown in the solution. First of all, we have to convert the units because both the units are different. So I am converting delta H into joule per mole by multiplying into 1000. By multiplying by 1000, it becomes 35,500 joule per mole. Now putting the values, delta G equals to 35,500 minus T into 83.6. Now for spontaneous process, negative term, that is T into 83.6 should be greater than 35,500 and T should be greater than 35,500 divided by 83.6. So T should be greater than 425 Kelvin. So option number A, the option A was that in which T is greater than 425. It is written by fault, option D. It is option A. Okay. Now look over the question, look over the solution, that how can we find the solution for spontaneous process. Before moving to next question, we have question from 2016. In this question, it is shown that which of the following statements is correct for the spontaneous adsorption of a gas. Look over the options. 4 options are given, and in all options the signs of delta S and delta H are used. So recall again the criterion of spontaneity, that delta G is negative when delta H is negative and delta S is positive. So option C is correct, that is delta S is positive and therefore delta S should be negative for a spontaneous process. Got it? Look over the question, how I answered it, how I recalled the spontaneity or criterion for spontaneity. So this is very important. Now moving on to the next question. Next question is NEET-UG 2014, in which the question is asked that for the reaction X2O4 liquid changing to 2XO2 gaseous, delta U is equals to 2.1 kilocalorie, delta C equals to 20 calorie per Kelvin at 300 Kelvin. The line is written again, hence delta G is, we have to find out the value of delta G. 4 values are given, 2.7 kilocalorie minus 2.7 kilocalorie, 9.3 kilocalorie minus 9.3 kilocalorie. Before solving, you have to remember that how can we solve this question. You have to remember 2 equations. First one, delta G is equals to delta H plus delta G is equals to delta H minus T delta S. Very common equation. Then another equation that I told you in previous video, delta H is equals to delta U plus delta Ng RT. First of all, you have to write down the values given and then convert the units and in desired form. Answer is given in kilocalorie per kilocalorie, so we have to convert the units in kilocalorie. I am converting delta S in kilocalorie by dividing it by 1000. It is giving 0.020 kilocalorie per Kelvin. And again we have to use the value of R, that is equals to 0.002 in kilocalorie per mole per Kelvin. Remember this value. Then we have to find out the value of delta Ng, that is change in number of gaseous moles. In the equation reaction given, change in number of gaseous moles is 2 minus 0, that is equals to 2. There are 2 gaseous products and 0 gaseous reactants. Now putting these values, we are getting delta G is equals to delta H minus T delta S. Putting delta H is equals to delta U plus delta Ng RT. This is minus T delta S. On putting the values, we are getting 2.1 plus 2 into 0.002 into 300 minus 300 into 0.020. On solving this, we are getting minus 2.7 kilocalorie. So the option was B, I think. So minus 2.7 kilocalorie is the answer. So look over the question, how I solved, and always remember, when you are solving numerical, first of all you have to check the units, then you have to remember the correct equations used, and then values of constants like R here. It is not 8.314 but it is 0.002 here in kilocalorie per mole, and also check the sign of your answer. Thank you for watching the video. If you are new to the channel, then subscribe to my channel as well, and also press